Welcome back to our channel, Automotive Uganda. We are now going to look into computers and how they communicate in our cars. I find this topic interesting because I think just yesterday, I found a video where someone was talking about how the US president was commenting when he sat in a Tesla car. He sat in the car and his remark was that it is all computer. And so they were making fun of him that he had just discovered that the car has computer systems, that they expected him to say that the car is all digital, but because he's from another era, he said it is all computer. So yeah, much as we're going to talk about computers, it is the same language. The cars have become so digital in so many ways. And this digital is what we see. The inside is the computerization of the systems. And as usual, Ivan is going to take us through these complex topics and make them easy for us to understand. You're welcome, sir.
Yes, thank you, Alan, my fellow Motormouth. Once again, I'm going to get straight to business. I'm going to share a short presentation on automotive. We call them automotive multiplexing systems because this is how cars operate these days. Briefly, what happens is this. For most of our viewers are aware that most of our cars now have computers in them. Not just one computer, they have multiple computers. But what are the computers we are talking about? These are essentially control computers. They don't work exactly the same way to the laptops or the PCs that you are used to. Essentially, they work the same way, but physically, their appearance is different. What your PC or tablet or laptop does, it takes inputs, processes them, and has outputs. For example, if you are typing, you are using it to type up a document, the keys you are pressing are inputs. Those are sensors. So every time you activate that sensor, the sensor for letter M, the sensor for letter Y, the computer, the CPU processes it and writes. It sends an output to your screen. It shows the letter, it shows the word my, because you press M and Y. So even in cars and industrial equipment, you have CPUs, you have, we call them control modules in cars. They are computers. They may be smaller than your PC, but they are still computers. They will take inputs, but this time, the inputs are coming in form of signals. For example, temperature, for example, speed, for example, position, resistance, voltage. That's what they are measuring. And that, whatever the signal is, it is transmitted by wires to that control module or the computer, which processes it. And depending on what the program is, for example, when you are using your word processor, your Microsoft Word, the program you are running is MS Word. It knows when you punch this, it knows what to do. When you punch that combination, it knows what to do. So it has a program written inside called MS Word to process your documents. Same way, these computers or modules in cars also have programs written by engineers that when you see the temperature get to this, command X, Y, and Z, command lower RPMs, command the electronic thermostat to open, and so on and so forth. Now, the challenge comes where you have multiple computers. You have one for the engine, you have one for the transmission, you have one for the instrument cluster, you have one for ABS, and so on. when they need to speak to each other. For example, the instrument cluster on your dashboard, for it to show you the correct speed, it will need to read the sensors, the data from the sensors on the wheels. But remember, the instrument cluster, the computer in the instrument cluster is not directly connected to the sensors in the wheels. The computer, for example, for ABS or the transmission may be the one which is mechanically or electrically connected via wires to those sensors. So that computer which gets the raw data is now able to send it to your instrument cluster or the dashboard without requiring separate wires from the dashboard to go to the sensors. Do you see how you now begin to eliminate wires when there is common data to be shared? And increasingly, there is a lot of common data to be shared. The air conditioning system will want to know how fast the car is going, in which gear it is, what is the engine temperature. There are so many things that the air conditioning control module will need to know to optimize your air conditioning experience. So it will need to speak to several. The air conditioning computer will be doing its primary job of providing you with air conditioning experience, but it will require data from several other computers. So instead of sending wires, which are going to add weight and complexity to the electric system, to each and every sensor with the data that the air conditioning computer needs, it will just instead talk to the primary computers which are directly connected to those sensors and get that data that way. I don't know if I'm bringing things into perspective. The reason why these cars are getting complex is because we like so many, they call them bells and whistles. We like to have so many new modern extras on them, but that complexity, having all these many systems, adds complexity to how these systems are delivered, how the vehicle is wired. It is going to become more complex. It is going to become heavier if every system has to connect directly to every sensor. So the function of automotive multiplexing is for reducing this complexity. The complexity of modern automotive wiring systems has been increasing steadily over the last 40 years or so. And recently it increased dramatically. It has now reached a point where the weight of the wiring harness is becoming a major problem. The way you can have these days vehicles, especially the electric ones, they need to be quite light. You already have a battery which is heavy. It is disadvantageous to have so many wires in the vehicle. So they are trying to reduce weight anywhere else on the vehicle. For example, the wiring harness. If they can remove like 2 kilos from the wiring harness, the manufacturer will do it. So the weight of the wiring harness is becoming a major problem. The number of separate wires now required on an ordinary vehicle can be in the region of 1,200 or even more. I've seen vehicles, I think, which have even 5,000 wires. It's just a mesh of wires. So, for example, the wiring loom required to control all functions in or from the driver's door can require up to 50 different wires in that door. So the systems in the dashboard area alone can use over 100 wires and connections. So this thing, it begins to add up. So this is clearly becoming a problem, as apart from the obvious size and weight issues, the number of connections and number of wires increase the possibility of faults developing. The more wires and connections you have, the more likely would you have of faults developing. It has been estimated that the complexity of the vehicle wiring system doubles every 10 years. So if you look at a vehicle of 1990, one of 2000, one of 2010, and one of 2020, and you look at the network of wires, you'd get the point. So the number of systems controlled by electronics is continually increasing. I'm repeating myself here because I've mentioned this before. A number of these systems are already in common use, and others are becoming more widely adopted and becoming standard on vehicles. Some of the more common ones are engine management, stability control, that is traction control, anti-lock brakes, transmission management, active suspension, communications and media. When you go into hybrid systems, that's another whole lot of wires and components, electrical components. When you go into electric cars, that's why you, like you said, the American president was amazed at what's going on inside cars. So all the systems listed above work in their own right, but are also linked to each other. Many of the sensors that provide inputs to one electronic control unit are common to all or some of the others. One solution is to use one computer to control all systems. One big computer to control everything on the vehicle. This would be very expensive because you need wires from this single computer to go everywhere in the car. And also, because vehicles have many variants, you have a 2025 Toyota Corolla with about 5, 7, 8 variants. You have a Toyota Corolla with a 1.2 engine, one with a 1.5, one with a 1.8, one with a 2-liter, and so on. Then you have a diesel one, then you have a hybrid one. Yeah, so you have, it's still a Toyota Corolla, but there are so many variants of it. So the wiring is going to be different for each of those different variants. So are you going to make one computer? How many different types of wiring harnesses are you going to have? So that makes it complex. So a second and better solution is what the manufacturers have now come up with, is to use a common data bus. So this allows communication between the modules and would make the information from the various vehicle sensors available to all of them. This is where electronic networks come in. For all intents and purposes, this network is not very different from a computer network you have in your workplace. If you have a workplace with the computers networked together, sharing the same internet connection, so you don't have, if you have 15 computers in the office, you don't have you don't need to have a cable, a LAN cable running from the, for example, the router to every computer. You can have one cable running to a router, which now distributes it. You don't have to, if you want to, for example, to print a document, you don't need to have a second, a wire running specifically from your computer, your PC, to the printer. Instead, what you have is one router which has one cable going to each computer. So when any computer on that network needs to print a document, the same cable that takes internet to the computer is the same cable that is going to be used to send out the printing job to the printer, which is also on that job. So you just need to print from your desk and go to the printer, wherever the printer is on the building, to pick up your document. So essentially, this is how I'm trying to simplify it to make it more understandable to our viewers. This is roughly how these computers are networking on these vehicles. Yes, networks are on cars. The same networks, okay, similar networks you have to in your workplaces are also on your vehicles. So manufacturers have developed and adopted a protocol known as CAN, or Controller Area Network. This system can meet practically all requirements with a very small chip surface, that is one that is easy to manufacture and therefore is cheap enough. CAN is suitable for transmitting data in the area of driveline components, that is between engine and transmission and ABS and so on. Chassis, that is things to do with the doors. Chassis systems also include airbags and things like that, and then mobile communications and entertainment. It is a compact system, which makes it practical for use in many areas. I'm not going to go into details. Of course, I'm skimming over a lot of the engineering details. I'm trying to simplify things here, but I want our viewers to learn the complexity of how our cars are designed these days, so that when they are handing over these vehicles to mechanics, they realize that you cannot just trust your newer vehicle to any joy car mechanic. So this is where we are now. To get a vehicle to operate, you even need complex networks like we are examining now. So this the image on the screen is an example of a network where you have three buses. There is a bus for the drivetrain, which connects this first one in the dark colors. It connects the engine control module, the ABS, the electronic stability program, and the transmission. If it is a four-wheel drive, it will also involve the transfer case. It will control the transfer case and so on. Yeah, if it has a ride height control, yeah, I think, yeah, the drivetrain will also include the ride height control, where you have cars which can change height as they are moving along, but usually those are high end. So you also have a second bus for the multimedia, which will display the information on the dashboard on newer cars. It will display temperature, play the radio, or even satellite navigation. Yeah, and then you also have a third network, which is for things like auto parking, the body computer that is controlling the alarm systems, controlling door operation, wipers, mirrors, that level. Yeah, so, but you notice that all these three different networks are all coming together at the instrument cluster at your dashboard, because you need to observe all these, the driver needs to observe different things about all these systems. So usually they come together. They are different, but they come together. So this is like the instrument cluster in this example is like the router. So all messages from all control modules are connected to a network, but these messages are sent to all units on that network, and each unit makes the decision whether the message should be acted upon by it or not. So once a module or a computer is connected to a network, it is designed to broadcast all the information from all sensors that it gets on the network. It doesn't care. But all the other computers on that network are listening. So there is a computer which is interested in the temperature, another is interested in the speed. So each one takes what it needs from the message broadcast by the first computer. And also these user computers which are listening are also broadcasting their information that they have gathered from their various sensors or their intentions. So you have that back and forth information going, going around the vehicle. This means that further systems can be added to the bus at any time and can make use of data on the bus without affecting any other systems. What do I mean by this? It means, for example, if originally the vehicle did not come with a CD player and you opt to get a CD player, you can install the CD player in the back, give it power and negative, and usually they will have left space for you to add this CD player, CD changer on the network, so that now you can command it on the original radio without changing anything else. Simply install it. It must be one that has been made for that vehicle, designed for that vehicle, so that it can understand the language on the network and so forth. So you can have a vehicle which, for example, did not come with the traction control, but you update the software in the ABS module and effectively turn it into a vehicle with the traction control. So these things are possible with just software patches. So that is the beauty of having these systems, CAN systems on vehicles. So among the benefits that of course I've already started explaining them in the previous slide, but among the benefits you get with the CAN operation is you have a smaller number of wires being required for each function. This reduces the cost and weight of the wiring harness, and it also improves reliability and serviceability as installation issues are improved. I discussed that earlier in the earlier slides in detail. So you also have general sensor data such as vehicle speed, engine temperature, and air temperature being shared. This eliminates the need for redundant sensors. You don't have to repeat so many sensors all over the vehicle for different systems because the systems are sharing data from, say, one sensor. The functions can be added through software changes, unlike older systems, which require an additional module or input-output pins for each function added. I discussed that earlier as well. So you can have new features being enabled by networking. For example, each driver's preference for ride firmness, seat position, steering assist, effort, mirror position, and radio station presets can be stored in memo profile. Many of you who drive German cars have already encountered those things. Yeah, so now the image is to show you an idea. It is from an oscilloscope to show you an idea of what those signals look like, those signals between the computers. That those electrical signals are how the computers talk to each other without misunderstandings. They have been designed cleverly to talk using those signals, those pulses. I'll not go into detail, but just know that is how they talk. That is the language they understand. Yeah, this is the same image, only expanded a little bit. All it is showing is that some voltage keeps going up and down, and you have it on two wires. One is the mirror reflection of the other. Yeah, thank you for your interest and listening all the way to the end of this presentation. So, Alan, if you have any questions or comments, I'll take them now. I know today it's a little bit technical than most of the other presentations we've made. Unfortunately, I can't find a way of breaking it into simpler terms.
Thank you very much for the explanations. My key takeaways mainly the fact that every 10 years, the car, multiply exponentially. It makes me wonder where what the future of cars and
I've remembered something, just to cut it short. I took a picture. I think I found this Toyota Corolla. It was an old Toyota Corolla. I think I found it in the Middle East, a very old Toyota Corolla from the 80s. You remember those DX models? It was yellow in color, and somebody had opened the bonnet. It was at an exhibition. It had a 1.8 liter engine, I think. The front, the bonnet, when you opened the hood, it looked empty. You could see the engine was there, but there was a lot of space around it. You could see through to the bottom. The wires were like only 20 or so, and this thing was running. The thing was running. It was in perfect condition, almost the same way it was produced from the factory. And you could see everything. It was like a skeleton, but this car was running. That is what we had in the 80s. Compare that with the 2020 Toyota Corolla, same engine size. Try to look into the engine bay. You see so many other gadgets and cables and wires and harnesses. So when you talked about 10 years, things changing every 10 years, the complexity of wiring is very, very different. Yeah, so you can go on. I'm sorry to cut you short, but I wanted to make that
Yeah,
point.
it's actually related because I'm trying to think of what the future of cars will really be. Because even when you just look at what the cars were when we were young,
Mm.
I remember there was, I think my father who had those old Land Rovers, the ones which used to have almost no gadgets. The dashboard was just
Just
dashboard.
you see one, two dials for temperature, one for oil pressure. That's about it.
And when you would open those vents, you would just get the air that is coming from the other side.
Yes.
Nothing special. The window, you put it up manually, everything is,
You
then you
remember the
have to look.
Peugeots which had those triangular things you would turn to open the on
Yes,
the
yes,
doors. They had a
yes, just to,
triangular glass piece which would open. So if you wanted more air inside, you open it some more. When it rains, you close it manually. That was the ventilation.
now you look at cars today. The other time I sat in someone's car and I had to ask her where is the gear, the lever for the, because I was not seeing it.
Yeah, they now come as switches. You just press a
Yeah.
switch. It's not
Mm,
even a lever anymore. It's just a switch.
mm,
You press some button.
mm. So sometimes I think about all these, gadgets that they have put and how most of them are just for touching. And I imagine, so when you are sitting there with your child, can't they, touch some of those things and trigger them off? Or you now have to strictly make sure they are sitting behind and strapped in
Yeah, that's why it
because
is important to have children in the back. I see a lot of Ugandans put young children in the front seat. Some actually carry them on their laps while they are driving. Imagine the nonsense. Imagine
yeah,
the danger.
because now the, the gadgets I think started with adding things on the steering wheel. Now the whole dashboard, this space for the gear, all that place is now for buttons.
Yes, it's essentially you are sitting in a cockpit, more or less.
Mm.
Yeah, and even the dashboards are changing. Forget the mechanical dials you had. They are now
Now,
like LCD screens.
yeah.
Yeah, so even if you see a dial moving, it is digital. Yeah, so you are going to have a lot of wires. And where we have gone with the hybrid cars and electric vehicles, a lot of those batteries, those drive batteries, you have a battery block that is made of smaller cells. Now, the computer needs to know the state of each of those cells. So there is a wire or two wires that are going to each of those cells. You may find a vehicle. I saw a video about the 2025 Toyota Prius. It was operating on 200 something volts, but it had about 72 different cells, which were connected in series to make up the entire battery block. So now imagine 72 different cells, each of them being monitored by the computer. So you need two pairs, rather 72 pairs of wires from the computer, the battery management computer, to each of those cells. Among other things, you have temperature sensors in the block. There were about 5 sensors. Then you had current monitoring systems. So many monitoring systems just about the battery. So you have a lot of wiring going on, and then that information has to be shared to other computers on the vehicle. The battery management system or computer sends whatever information is required to the engine management computer or whatever computer is in charge of the motors. So Yeah, cars have become so complex, wiring-wise or computer-wise, that networks are inevitable. So now we approach vehicles, you can no longer rely on your knowledge of how to use a spanner. You also need to go in, one, as a computer geek. Two, you have to understand the networks. Because computer geek is somebody who is programming things. But a data network guy is a guy who will come and troubleshoot cabling, network cabling. So do you realize how many hats your mechanic is now wearing or requires to wear? And do you think you are going to continue paying them the same 5K, same 20K you've been giving them? No, you cannot, because first of all, they will not be able to buy the equipment that is required to repair or maintain your vehicle. Secondly, they need to go and gather that information. They need to go back to school. That costs money. So as you are buying these newer and newer cars, just know they are not going to leave you the same wallet-wise. You are enjoying all these new technologies coming into the vehicle. Just know you are going to pay for them. And for you, the mechanics who are out there, if you are not willing to go back to learn these new things, I think your days in the business are numbered.
Yeah, how the world keeps changing. So cars and car manufacturers have started transforming into technology companies that make cars, as opposed to cars being made with technology. Now it is more of the other way.
Yes.
That is why I think the Chinese are giving these people a run for their money, because for them, they have mastered the technology side of things, and this other mechanics is the simpler one. So they are making cars which have all sorts of things inside, and the luxury brands have struggled to compete with that.
And the people generally believe that these newer cars are harder to maintain or troubleshoot, simply because we all inherently have a fear of the unknown. We are not used to electricity being in cars, wires everywhere, networks, what sounds complex. In reality, the latest internal combustion engine cars are the most complex, because you are putting together mechanical systems that are controlled electronically. Whereas in an electric car, everything is electronic, everything is about electricity. You are not trying to marry mechanical and electrical stuff. So you only focus mostly on electrical side of things. With the modern internal combustion engine, you have to mind the mechanical side of things, while also in the back of your mind, you are thinking about electrical issues. So as you are investigating why an engine is not starting, you may have to investigate whether the cylinder, the valves are broken inside. That's why the vehicle is misfiring. You understand? At the same time, it may be the coil, the ignition coil. At the same time, it may be the sensor. All those can cause your misfire. With an electrical car, if there is a broken wire or some broken solder joint, the vehicle is simply not going to run, period. So now you have to trace just that broken wire, and all your issues will be resolved. So while you are troubleshooting an internal combustion engine, you have to wear two hats, and then you keep changing, depending on what you have to keep changing those hats, depending on what symptoms you are seeing. With electricity, it is easier. If you understand how the electric car is working, it is easier to troubleshoot. In any case, the computers that they are using on electric cars are much more definitive when they give you error codes. When you plug in the diagnostic computer, it will usually pinpoint that I have a problem on this relay. then you look for that relay and find out what the problem is with it. But an engine, internal combustion engine, turns up misfiring. It could be the oil, it could be the fuel, it could be the mechanical state of the engine, and so forth. Yeah. So unfortunately, Alan seems to have just gone again. I'll wait for a few more seconds. If he doesn't come back, we shall end this video here. I think we have discussed more or less what we needed to. But just to make a few more points to our viewers, you need to understand that what we consider as complex electrical systems in cars are somewhat inevitable now. We're already on that path. We cannot turn backward. And all the things are being done to make cars not only cheaper and more affordable, but also safer and more environmentally friendly. Somebody is going to ask, oh, the newer cars are always more expensive than the older cars. Of course. But if you look at the cost of owning in 1985 Toyota Corolla, just in the consumption of fuel alone, and you compare it with the cost of fueling a 2025 Toyota Corolla internal combustion engine, same engine size, there is a big difference. So if you are going to drive both cars for 20 years, it's going to be cheaper for you to operate, to run, to fuel a 2025 Toyota Corolla for 20 years than the one from 1985. The one from 1985 is not as fuel efficient. So these things are intentional. Upgrading electrical systems on cars are intentional. Thank you very much for sticking through to this point of the presentation. Bye-bye.